In this lecture, we see what is the absolute value or modulus of a complex numbers. The absolute value of complex number are the modulus of complex number z equal to x plus iy is defined by non-negative real number root over x square plus y square and is denoted by mod of z. Thus, mod of z equal to root over x square plus y square, which can be also written as root over z into conjugate of z, which is always greater than or equal to 0. So this is called absolute value or modulus of a complex number. For example, modulus of minus 3 plus 4i, which is written as, which is equal to root over minus 3 square plus 4 square. So minus 3 square is 9 plus 16, which is equal to root 25, which gives us 5. So modulus of this complex number minus 3 plus 4i, which is given by 5. Geometrically, mod of z is the distance of the point from the origin. Consequently, mod of z1 minus z2 is the distance between 2 points z1 and z2. Now, the second very important concept of a complex number is argument or amplitude and polar form of a complex number. The polar form of complex number z equal to x plus iy is defined as z is equal to x plus iy, which is given by r times of cos theta plus I sin theta, where r is equal to root over x square plus y square. This is nothing but the modulus of a complex number, and theta is equal to tan inverse of y by x is the amplitude or argument of the complex number, which is denoted by AMP of z or ARG of z. In first quadrant, theta is equal to argument of z, which is given by tan inverse of y by x. So now, if we so the complex number can be represented in Argand diagram. And what is Argand diagram? Argand diagram is nothing but the geometrical representation of a complex number. So this is called, x-axis is called real axis and y-axis is called imaginary axis. So if any complex number lies in the first quadrant, for example here, so the argument is given by tan inverse of y by x. For example, suppose it is x plus or 2 plus 3i. Then what is its argument? Theta is equal to tan inverse of 3 by 2. This is called argument of a complex number 2 plus 3i. Similarly, in the second quadrant, theta is equal to argument of z, which is given by pi minus tan inverse of y by x. So now, if any number lying in this quadrant, second quadrant, suppose it is 2 minus 2 plus 3i. So its theta is given by, argument is given by theta is equal to pi minus tan inverse of 3 by 2. So this is called argument of the complex number in the second quadrant. Similarly, in third quadrant, theta is equal to argument of z equal to pi plus tan inverse of y by x. So now this is in the, this is third quadrant. So here its argument will be pi, because this from, we have to measure from this point. This is theta equal to 0, theta equal to pi by 2, this is pi by 2, and theta equal to, this is theta equal to pi, theta equal to pi, and this is theta equal to 3 pi by 2. So now what is the argument in the third quadrant? It is pi plus tan inverse of y by x. Similarly, in fourth quadrant, theta is equal to argument of z, which is given by minus tan inverse of y by x, or sometime it can be also written like that, 2 pi minus tan inverse of y by x. So these are the different terminologies, are very important terminologies in complex number, which is modulus and amplitude are argument of a complex number. Properties of argument of a complex number. First, argument of z is equal to argument of x plus iy, which is given by theta is equal to tan inverse of y by x, this y by x. Second, argument of multiplication of two complex numbers z1, z2, which is given by argument of z1 plus argument of z2. The third property is argument of z1 upon z2, which is equal to argument of z1 minus argument of z2. The fourth properties of argument is argument of z to the power n is equal to n times of argument of z. Argument of its conjugate, which is equal to minus of argument of z. Now, the third form of a complex number is exponential form of a complex number. The exponential form of complex number is given by z is equal to r e to the power I theta, where r is equal to root over x square plus y square is the modulus of the complex number, and theta equal to tan inverse of y by x is the amplitude or argument of the complex number. Now, Argand diagram are graphical or geometrical representation of complex number. A complex number z equal to x plus iy can be uniquely determined by ordered pair xy of real numbers. Since there exists one-to-one correspondence between the ordered pair of real numbers and point on the plane, every complex number can be represented by a unique point in the Argand diagram. Thank you.